Welcome back. We are on day 2 now, and I'm glad I didn't scare you away yesterday with all of the code and everything, but now we're going to code even more. The first thing we're going to do is open NetBeans, and last time we talked about cars. We made a car class, we made a car blueprint. What does a car have? What defines a car? Stuff like that. In our class, as it loads up here, we had properties. We had these fields that said, okay, we have a max speed, a min speed, a weight. This is what a car is made of. This is what we can say about a car. And we also had methods down here to either display these properties or to even change them. And so we're going to start off today by creating a couple more properties. And so we'll add some space in here to kind of clean this up. We'll add a space between min, speed, and weight. Add a space between weight and is the car on, and then another couple spaces here after name of car. And we're going to add some stuff. And so the first thing we're going to add is a double, and this will be a max fuel, and then we'll say equals, which again will assign a value to this property. And so the max fuel, the max number of gallons that an average car has is 16, so we'll put a value in there, 16. And when we wrote out the statement, basically we declared the fact there's going to be a property called max fuel. We allocated space within the computer memory saying, okay, make space for this double. And then we gave it a value, we initialized it. And so those are 3 big steps in creating variables. And so we're going to do all that again in another instance variable that we are going to create. And we're going to say double current fuel. And if I just put a semicolon here, we are only declaring the fact there's going to be a property called current fuel and allocating space for this double. But we aren't giving it a value. Well, obviously we're not giving it a value because there's no number associated with this current fuel. It's not initialized. And we can initialize it just by doing equals. And then we'll say every car starts off with a half a tank, so 8. And you might be wondering why I made these doubles, and that's because 16 and 8 are going to be in gallons, and there is going to be a point where you're between 8 and 9, or you're between 7 and 6 gallons of gas, and you need kind of a middle ground here. At some point you might have 8.5 gallons, or whatever it may be, and so by making this a double, we allow the fact that the current fuel could at some point be a decimal value. But right now they're whole values because those are nice to work with. And we will add another instance variable here called double, MPG, again, miles per gallon. And the average miles per gallon for a car is 26.4. Add a semicolon. We are declaring the variable MPG, allocating space for this double, and then giving it a value, initializing it. Those are the 3 big steps in making your instance variables, your fields, your properties. Very, very important. And we're going to create one more field property here. And we are going to go int and then number of people in car. And this will just be how many people are in the car right now. And so we'll say equals, and we'll say the average car has 1 person. Then do a semicolon. And again, it's an int because you can't have 1.5 people in the car. We're just not going to do that. And so we'll separate this out by putting a space in between MPG and the number of people in the car. Do another space down here to separate it from our functions down here. Last time we kind of talked about how these variables up here and the functions down here go together in a way. We have methods down here that can change or display these properties. Now everything up here is called an instance variable. All of these together are called instance variables, and basically these right now are set with the default values for the average car, but they can change on each instance of a car. Like every car doesn't have to have a weight of 4,079, and maybe it has more of a fuel tank. It has, say, 24 gallons of gas versus 16. And before, if we scroll down to our main function, we created a car with these default values by doing new car, open parenthesis, close parenthesis, and then we just changed these values later by doing our upgrade min speed method, which changed the instance of our family car. So before we get any deeper, let's talk about what this all means. Here, our main function can be kind of confusing because this is where we actually make everything. We made our instances here, we made our family car, we changed some stuff about it, it might be easier to think of our main function as our body shop. This is where we create our new instances, we change stuff, we actually use the tools in our toolbox to create new things. Now our tools are our methods here, and so upgrade min speed, print variables, those are functions that tell us what's up with our car, and we use these functions on the cars we create here in our main function. And so notice how I did family car dot print variables or dot upgrade min speed, and we use these tools on our instances. We upgrade our cars, we downgrade our cars, whatever we do them to the actual car, which is our family car, inside of our body shop, which is main. And up here we have these properties of the car that tell us, okay, what can we change, what can we use, what can we do inside of these methods that again are operated on the instances that we create. So going back to what we were talking about earlier, we had to first create our family car before we could change any of the family car's values, like its min speed or its condition. We had to create the car first before changing any of that. But there's actually a way where you can create a custom car that doesn't start off with all of our default values up here. When we create any car with this new car initializer, we create a car that has all of the default values. But we can use a custom initializer that will allow us to change or really set these properties up here. So how do we do this? We use something called a constructor. So if you go to where your fields are and then go a little below that, that's customarily where you're going to put your constructor that literally constructs the car, creates an instance from the stuff we have in our blueprint. And so the first thing you're going to write is public, and this is like where you can create these cars. We're going to say anyone can create these, and so we'll say public. So we'll just go ahead and write car, and this name right here for the constructor has to match the name of the class because you are creating an instance from the blueprint, which is the car. So this has to start with car, and then we do open close parentheses, and then we can put our curly brackets. And so right now we're essentially overwriting this method right here, which says create a new car. But we don't want to just create a new car and do nothing. We want to create a new car and give custom min and max speeds, for example. And so we can actually do this by adding parameters to our function right here, our instance method. And a parameter is just a special kind of variable that's used in a function to refer to a certain piece of data that's inputted into this function. And so we do this by saying int, and we could say custom min speed. And right here, int is the data type for this parameter that we are putting in, and this is the parameter name. So if I go down here, and we are just going to delete all of this here, and we're going to say car, and we'll say birthday present because we're getting a new car for our birthday, and we'll say equals, and then we'll say new car, and then we'll put in a value for our min speed parameter. So say we want the min speed for our birthday present car to be 10. Well, we'll just input 10. This value 10 is called the argument, and the argument is just the piece of data that's passed into the function and becomes the value of the parameter min speed. So 10 here is the argument, and it is going to be put in as the custom min speed. So it's kind of like in math where you do f of x equals x plus 1. That's a function. Now we could say x equals 5. And then we'll have f of 5 equals 5 plus 1, and so the answer is 6. That's kind of what we're doing here. Here, 10 is our x, and we're plugging it in to custom min speed. Now let's say I don't put 10 in here. Let's say I put false. It's going to error because false is not an integer. It's not a whole number. It's a Boolean. And so we'll put 10 here. And will this automatically set the min speed to 10? Well, no. We haven't done anything in the function. We've just said, okay, public car, we're going to create a new car. This is a local variable we want to use, but we haven't used it yet. So how do we use it? Well, we literally set the min speed to this custom min speed value. And so we can say min speed equals custom min speed and then semicolon, and now the min speed is set. If we did this the opposite way, if we did custom min speed equals min speed, it would not work. The min speed would stay at its original value of 0, and custom min speed would be changed to 0 as well. But because this is a local variable here, nothing's going to happen, just nothing will change. And so we need to make sure this ordering is correct. So we'll change this back. We'll put min speed at the front here, assign it to be the value of our custom min speed. And we can actually do this for all of our parameters, but we're only going to do it for a couple because time. But you can mess with this in your free time if you would like. And so let's set another property up here. Let's say we can have a custom weight of the car. And so we'll say double because this type up here should match this type here because we want to do a custom, and we'll write custom weights. And then we'll say a Boolean, and we'll say custom is the car on. And so these will be the customizations that we can make. Everything else will start at its default value for car, but we'll say we can have a custom weight, a custom is the car on, and then a custom min speed. And to make this more real, we can actually change this to max speed, and then change that to max speed, and that to max speed. And there we go. And you don't have to call these custom max speed, custom weight. You call them A, B, C, and D. But it's nice to see, if you're wondering what's going on, to name them something appropriate. But as long as custom max speed here matches the custom max speed here, and that you assign the correct things to the correct names, and everything matches up kind of like we do in math, then it should all work out. But again, it's nice to read if it's something appropriate. And so we'll go down here and we'll have an error. That's because now we don't have a constructor that just takes the custom max speed. So when we create a constructor, or any function really, we have to make sure that we put arguments for all of the parameters up here. And so right now we only have one argument and we have 3 parameters. And so let's put some stuff in. And so we'll say the max speed is 500, and then we'll do a comma. And that's what separates these different parameters or arguments, parameters up here, arguments down here. And then we'll say our custom weight, we'll say it's a pretty big car, so we'll do 5,000.5. And you could just do 5,000, it would work because every int is a double, but not every double is an int. And so we'll do 0.5 for 5. There we go. And then we'll do another comma to separate that out, and then we'll do custom is the car on. We'll say it is on, so we'll say true there. Again, if I put an int or a double where this lines up here, then it would error. And the order of these arguments does matter because 500 is going to match up with custom max speed, this number is going to match up with custom weight, and true is going to match up with custom is the car on. And so right now we've set our max speed here, but we will add a space and say weight equals custom weight. And we got to remember that semicolon. And then we'll do is the car on equals custom is the car on, and then semicolon. And just like in math, we have f of x, we could do x, comma, y, comma, z, and then change our function a little bit. You could do divided by z minus y. And in math here, just like in our function, the difference between x, z, and y matters. Putting them in the right order matters because you don't want your z, which you think is adding, to really be dividing or something like that. And so as long as you put in the correct order here and you know what it's going to match up with up here, everything will work out. And now we'll delete the space here. And we can print some stuff out to see this actually works. And so we'll go birthday present. We'll do birthday present dot print variables because we've already created that function. Do a semicolon and we'll run it. And it'll run. We'll pull up this console here and we'll say here this max speed is 500, and that's good because we set 500 here. This min speed is 0, which is good because that's our default here. We have our weight, which has been set to 5,000.545 because we set it in our constructor here. We made it custom by adding this custom weight and then making it equal, assign it. And then our car is on, so that was set to true because we put it in our constructor customization there. But notice the default was false, and then A and Lucy all turned out to be the same. So it's common to have constructors like the one right here, set every single property that you have because the programmer might want every card to be unique. But it isn't necessary as long as you set default values. So let's scroll down here and make another card just for practice. And we'll say car, and we'll say Christmas present. And this one's really special because it's your Christmas present, not just your birthday present. And so we'll say new car, and we'll say it goes up to 550 because it's like a sports car, very fancy, and it's pretty small, you know, because sports car. And so we'll say it only weighs 2,000 pounds. I don't know what that really means in the car world, but sure. And then we'll do another comma and we'll say it's off. So we'll actually set it to the default value and see if anything happens. And so we'll say Christmas present dot print variables, so we can see what everything is. And then we'll add another print statement up here with system.out.println, and we'll say birthday car, and then we'll copy this, put it below, and then say Christmas car. And we'll hit play. And let's see what happened. All of our birthday car stuff down here stayed the same, so that's good. And down here, our max speed is now 550. Now, creating this new object will not affect our birthday car because we're initializing creating a whole new object. And so nothing that we do to the birthday car is going to affect the Christmas car. And so we'll scroll down. We have our max speed 550, 2,000 pounds here, and then false, false. And so even though it was default false, we set it to false, so it's going to be false. And nothing else changed. So now you know how to construct custom objects. Very exciting with your constructor. So now I'm going to show you how to use math inside your code and how you can make it work to your benefit. And so we're going to do this by creating more instance methods. And so if we scroll down, notice we used addition here, and there are a couple other ways we can use math inside of our instance methods. And so we're going to write public, and we're going to create a method that allows people to get in and get out of the car. Of course, using code, and so it won't be actually getting in and out of the car, but it will be represented with what we write. And so we're going to do public void, and we're going to say get in is going to be the name of the method, and then we'll have an open close paren, open curly bracket, hit enter, it'll close the curly bracket. And what does it mean for someone to get into the car? Well, in our code it means there's one more person in the car. So our number of people in the car will go up by 1. And so this will be very similar to our upgrade min speed, where we do number of people in car, and then we'll say that equals number of people in car plus 1. So what this means is that if there are 5 people in the car originally, 5 plus 1, if someone gets in, there's 6 people in the car now. And the reason we use number of people in car as a variable here is because we don't know how many people are in the car originally, only our property does, and so that's why we call it here. So get in, one more person gets in the car, and so the number of people in the car is updated. And we can actually simplify this by doing just number of people in the car plus plus. And this means the same thing as number of people in car equals number of people in car plus 1. And so it takes the original value, increases it, and then saves that in the original values variable. It's just a simpler way to do this line of code right here and say, here's the original value, I want to increment it by 1. And so that's what we do. We can also do this with subtraction, and so we'll create another method, public void get out. And so you're kicking someone out of your car. So we're going to do the same thing. We'll do number of people in car equals number of people in car minus 1. And again, this can be simplified to number of people in car minus minus. Notice all of our mathematical functions work perfectly here. We just have to call them with the subtraction sign or the addition sign. It also works for multiplication and division. And so we'll hit enter again. We'll create another instance method, which will change another instance variable up here, another field property value. And so we'll do public, and this time we'll return a double, and we'll call it how many miles till out of gas. We'll do open close parens, open curly bracket, close curly bracket, and we're going to figure out how many miles do we have until we run out of gas. How do we do this? Well, we can scroll up, see what we have to work with our variables, and we know what the MPG is, and we know how much fuel we have now. Well, if we have 8 gallons now and we get 26.4 miles per gallon, we can just multiply the two and get our answer. And so we'll want to return our current fuel, which will have the current number of gallons that we have, times our MPG. And that will return a double, and then we can see how many miles do we have until we run out of gas. And we'll create one more instance method by doing public, and this will again return a double, and we'll say this method will be called max miles per fill up. And this will tell us if we are given a max fuel tank, if we have everything in our fuel tank, how many miles can we go? And so this will be similar to our how many miles till out of gas. We'll do return, and then we'll say max fuel times MPG. And this asterisk here is the sign for multiplication. We haven't done an example with divide, but if you wanted to do divide, it's just a slash right here. And you could use division in your code. But we want to use multiplication right here, and so there it is. Now you might be wondering, why are we creating all of these methods? Can't we just say max fuel times MPG? Can't we just do that right here in the main? Well, yes you can, but you don't want to do that. The whole goal of computer science is to be able to change things easily, to have everything so spread out so that way if you have an error, you can just go to the one method or the one function that's causing problems and fix it really quick. If you have, say, 2,000 lines of code inside of this main function right here, then it's going to be really hard to track down, okay, where's the error? These 100 lines work, but something's going wrong below. How do you figure it out? Well, by separating your code into a lot of functions, you can track things down easily. Also, by creating these functions, it allows you to save certain methods. And so I never have to go max fuel times MPG 3 times down here because I already have it saved as this method. Yes, I'll have to call this 3 times, but I don't have to write whatever's in this method a bunch of times as well. Now, our methods here are only a line or two, but in the future, when you create really big projects, sometimes you'll have 20 lines in here, and so instead of writing those 20 lines over and over again, you can just call dot print variables or dot whatever the function is right then and there. In a way, computer science is pro-procrastination because you can just say, oh, I'm going to do birthday present dot, and then create a function name and make the function later. But you can have the main part of your code all ready to go before you even create the other stuff later. So back to our code. How do we know all of this works? How do we know all of these functions will actually change our instances and that we can use multiplication, subtraction, and addition right here in our code? Well, we can print some stuff out and see what happens. So I'm going to comment out our Christmas car, and basically commenting means that it won't be read by the compiler, and so that means this will not be evaluated. It's just kind of like notes for whoever's programming. It's 100% for people and not the computer, because besides like commenting out certain parts, it can also tell you what things mean. Like up here when we have get out, these 2 lines, 55 and 56, say the same thing. But it's nice to know what this down here means. But again, not read by the compiler, has no programmatic function. And so we'll say goodbye to our Christmas car. We'll hit enter a couple times, give us some space. And at the beginning, we'll print our variables, and so we'll have this, and we'll create our car first. Kind of move some stuff around here, and take that space away. And then at the end, we'll do the same piece of code, and we'll say birthday car V1, birthday car V2. And we'll mess with some code. And so let's call some of these. Let's do birthday present. Let's invite a bunch of people to get in, so we'll do birthday present dot get in, open close parentheses, and we'll invite 3 people into our car dot get in, open close, and we'll invite one more person to get in dot get in, And so now we should have 4 people in our car because originally we start off with 1 person in our car. Then we'll print out how many miles till we're out of gas. So we can do this by system.out.println, and we'll write miles left, format it, do the plus, do birthday, present dot how many miles till out of gas. And this will actually return and put it in the string how many miles we have left. And so that's what it means to return something. Here we return nothing, so we just kind of say birthday present dot get in, but here we want to know how many miles are left, not just run it and then throw away the answer. Here we put the answer in a string. And then we'll do this again for system.out.println for the max miles per fill up. Max miles, and do the colon. And then again do birthday present dot max miles, and it'll auto-complete for me, which is really awesome. Semicolon. We'll print out our second version of the birthday car, and then we'll have a third version. So we'll copy this again, paste it, do the system, add the semicolon, and we'll tell 1 person to get out. So we'll do birthday present dot get out. Add the semicolon, and then let's save. Super important. And then the next thing we have to do is print out how many people are in the car, so we can add this to our print variables up here, system.out.println, and we'll say number of people in car, because that's the thing we're testing. Both of the how many miles till out of gas and the max miles per fill up, those will stay the same, or the answer of those will stay the same because we're not ever changing our current or max fuel. So that's why we only print them out once down here. And so now we'll press play, and the value for number of people in car should change a bit since we have people getting in and getting out of the car. And so we go up here, birthday car V1, we have our max speed. This will all be set because it's a custom initialization with our constructor. So all of that stays the same. And then down here we have 1 person in the car, which is good because no one's gotten into the car yet, no one's gotten out. Our default value is 1, and we didn't set it to anything special here in the constructor. We'll scroll down. We'll assume the math is correct, but notice both of them are decimal values, so it's a good thing that we set the return type to double. And so now we know our max miles and our miles left. And we can actually check this here because 211 is about half of 422, and we had half a tank of gas initially, so this looks like it works out. Then we have our birthday V2. What happened? 3 people got in, so we should have 4 people in our car, and everything else should stay the same. Down here it does. We have 4 people in our car. Everything works. We scroll down. We did V2 again here, so that's why V2 is down here as well. We got to change our code if we want this to change, so we'll just change this super quick to V3. We'll scroll down. Everything should stay the same except 1 person gets out, and that is true down here. So in this video, we talked a lot about variables, how to declare, allocate space for them, and initialize them with a value. We talked about functions and methods, what an instance method is, how that relates to our instance variables, and how you can create instance methods that will change your fields, your properties, your instance variables. We also talked about how to initialize a car with custom values, and so how to create a custom max speed, a custom weight on initialization. We talked about math and how we can use it in our programs, how we can use add, subtract, multiply, and divide to do stuff in our code and create methods that will change our properties. As always, the HackerRank challenge is down below in the description, and if you have any questions, feel free to leave a comment on this video and I will answer it. I'll see you tomorrow. Bye-bye.